And we're live. Hadassah, go ahead.
Zach is using his knowledge of geometry to design a gazebo for his family's backyard. The gazebo will be in the shape of a regular polygon.
Yeah.
As part of his design, Zach will need to calculate several things so his parents can purchase the right amount of wood for construction. For example, Zach will need to calculate the perimeter of the gazebo so that he can order enough railing to surround it.
I'm going to annotate this as we go. Calculate the perimeter. I've got a sneaking suspicion that we'll be doing something like this.
Calculate the area.
He will need to calculate the area of the floor of the gazebo so he can order enough planks to lay it. And he will need to calculate the surface area of the pyramid which forms the roof that will cover it. The problem is, his parents keep changing their minds about what shape they would like the gazebo to be. An hexagon, an octagon, a decagon, a dodecagon, or even some other type of engon.
Ugh, parents, am I right? Parents.
From his work in Mathematics 1 with symmetries of regular polygons, Zach knows that all regular polygons are cyclic. That is, every
What was that?
God bless you.
I don't know. Every regular polygon can be inscribed in a circle. Zach is wondering if he can use this property of regular polygons to help him find their perimeter and area. For his first attempt at creating a scale drawing of the gazebo, Zach has inscribed a regular hexagon inside a circle with a radius of 2 inches.
Nice.
He is wondering if this is enough information to find the perimeter of this hexagon and the area it encloses.
What if I want a triangle?
Well, I can't say regular anymore, apparently.
Regular? Yes, ma'am.
Just regular.
Right now?
A triangular
Okay, I'll wait.
gazebo.
Well,
I'm kidding, I'll wait.
I don't know if we'll have...
I wait then.
You got
Bruh.
Hey,
Hey,
now
now calculators.
Okay, all right, here we go. So we have a lot of things, and he's wondering if it's going to be possible to find the hexagon. The first thing that we're going to do, number 1, find the perimeter. Yes.
Also, because it gave us the radius.
Oh, yeah, where could I put the radius?
Technically, you're wrong. Number 1 is putting the radius.
Whoa.
Question number 1, Jacob, simmer down with the sass. Sheesh. Yeah, I can just go ahead and put a radius right here. Okay? I'm going to give you a little hint. It will also be helpful to put this radius right here. And now what do you see?
Triangle.
Triangle.
A triangle.
Well, it looks to be
Also,
equilateral.
one thingy,
One
what's it called?
isosceles, but you can't.
Yeah, it looks either isosceles or equilateral. Can we determine if it is isosceles? Remind me, what does isosceles mean?
Two equal sides.
2, right.
It would be because they're both saying that the radius is 2.
So we know it's isosceles. It may be equilateral. It looks like it. We're not certain yet, though.
There's a lot of them.
What else do we know about this triangle?
What else do we know? It's red sides. Yep.
Okay, let's be more analytical than
Are
color.
the angles the same?
Do we know that?
Well, we couldn't find the
Two.
missing sides because we have 2 of the.
We can only do that if it's a right triangle with the Pythagorean theorem. But hold on, let's talk about angles for a second more.
The two bottom angles would be.
So we know that the 2 bottom angles would be the same. This would be and this would be, because it's isosceles.
And the arc would be half of the.
Well, the arc, for a central angle, the arc would be the same, right? Which is cool. Let me ask you this question, though. If I were to make this triangle, is this triangle over here the same as this triangle?
You would assume.
Yeah, right? And is this triangle the same as those 2 triangles?
All triangles would be the same.
So the triangle is going to be 1/6 of the entire thing, right?
Yeah, I just got really wide when I said it. It was just. I was like,
Which means this will need to be 1/6 of the entire angle measure of the circle.
So, could you do 360 divided by 6?
Yeah.
That'd be 60.
So this whole thing is 60 degrees. And then if the bottom left and bottom right are also congruent,
Equilateral
Oh, they're both 60 as well because they all three have to add up to 180. Yep, 180. It's just
Gotta
process. Yeah, so they all have to add up to 180. So that means that this is 60 as well. This is 60 as well. And now I know that that's an equilateral triangle too. Okay. Before we move on, Jacob said something about finding the third side with the Pythagorean theorem, but we can only use that on triangles that have right angles. So what I'm actually going to do is I'm going to make a right angle by dropping an altitude. Okay, now I don't necessarily have to construct this. I'm just going to like make it as close as I possibly can. But I'm going to state some things about what I know an altitude does, especially in an equilateral, well, especially in an isosceles triangle, which this is even further than an isosceles. It's a equilateral triangle. But this cuts the upper angle in half. So now what's half of that circle? Or circle, yeah. Angle is what I meant. And down here on the base, what's half of this as well? 1. Okay. We're going to use that information later because all it asked us for in number 1 is what?
The perimeter.
The perimeter, right? We already found out that the base of this triangle, since it's equilateral, is 2. So how could we find the perimeter of the rest of this hexagon? Because I knew that this triangle's got to be the same, right? And this triangle's got to be the same. So if they're all the same, what is this side right here?
2.
That one's going to be 2. And this one?
12.
Yeah, how did you find that out?
2 plus 2 plus 2 plus 2 plus 2 plus 2.
What's maybe a simpler way to do that?
2 times
2.
7. 6.
6. 2 times 6 because we know that, oh my gosh. Right, multiplication is just repeated addition, right? So if we're doing 2 plus 2 plus 2 plus 2, 6 times, we could just say, oh, let's just do 2 times 6. Easy money. So, one side is 2, and all sides is 2 times 6. Boom, there we go. There we go, there we go.
If the parents change their thought on the shape multiple times,
Yeah, so
when did you
right now we're doing a very specific one, but then we're going to start looking at, okay, are there ways that we can extrapolate from this a general procedure, okay, or formula even? That's what the next couple of lessons are going to be about. Now, this is actually kind of interesting too, because people are always like, what am I ever going to use math for? Well, if you ever want to build a gazebo, which I actually kind of hope to in my life, build a gazebo because they're beautiful and fun.
Build one here.
That'd be cool.
That would be super cool.
Yeah, right here.
No, not in this room.
And you can get students to help you for service.
Yeah, I would help you for
Really
service
cool.
hours.
That's a great idea. I'll have to.
Play music while building. That'd be a lot of fun. I love my brain into
Okay.
Yeah.
So,
Like theater,
there's the
like,
perimeter.
musical.
High School Music. We're all.
Oh, we were not supposed to find the perimeter
And
yet.
then magically
Too
you
bad,
build
so
the gazebo
wow.
within 4 minutes.
We're gonna go through here. We kind of talked through some stuff already.
What were we supposed to find first?
The perimeter, but not the perimeter.
We were supposed to decide if we disagree or agree with these statements. So, let's go ahead and retroactively do that now. Someone want to read that first one? Jacob, you could read the first one.
Two move radii drawn to 2 consecutive vertices of a regular hexagon form a central angle whose measure can be found based on the rotational symmetry of the figure. We agree with that.
We agree with that, right? Because this has rotational symmetry of 60 degrees, and we found that it also is 60 degrees, yeah?
How would you explain it? Yes, because it has rotational symmetry of 60 degrees.
Yep.
I'm slightly scared for myself because I'm slowly. Everything's like, ooh, words make sense. with
Yay. Yeah, I'm also scared for you for that.
math. Thank you.
So me Meanwhile, there's me that understands words but doesn't understand math.
Oh.
Then there's me. I don't understand both.
Okay, the next one, a hexagon, can be decomposed into 6 congruent isosceles triangles. What you think?
Yes.
Why?
Dude, but
Because the radius is 2.
The radius remains, the radii
Remain.
are congruent. Let's say that. Are congruent.
I don't like the word radii because of the 2 eyes at the end. 'cause it doesn't
It's like Hawaii.
All of
Mm.
Is
Radii-
radii
seem
and
right.
radii and radius, is it the same thing?
Radius is singular, radii is plural.
Oh.
Yeah. Just like Hawaiius is single and Hawaii is plural.
Hawaii.
What?
I just made that up.
Okay.
I'm gonna be honest, I just made that up.
I don't
don't
think
like
so.
Hawaii is singular. Hawaii.
Hawaii.
No, that's just
Yeah.
what all the islands are. They're Hawaii's. And then
Before I-
Hawaii
I take the
is the entire
Hawaii.
group of islands.
These
Probably, yes. But you're gonna.
Mr. Ball, you actually make a little bit of sense.
Okay.
Hawaii is just one island. Hawaii is all the islands.
That's true.
Wait, no, but Hawaii is the name of an island.
Yeah, that's true.
Yeah, they all have different islands.
All right, here we go. Samantha, will you read the next one?
Like that. That was really close to my ear.
Sure. Okay, go.
Length of the altitudes of each of these 6 congruent triangles, the altitude drawn from the vertex of the triangle, which is located at the center of the circle, can be found using trigonometry.
Ooh, so that's this thing right here. Could we find that, what I've labeled as H there,
The altitude.
using trig?
Yes.
Okay, how could I do that?
1 minus 2.
They said using trig, though, not the Pythagorean theorem.
Wait, what
No,
would
because
that
we know
be?
we have the 1 angle of 90 degrees.
We've got one angle that's 90 degrees, so what are my trig functions? I've got 3 of them.
Oh, sine, cosine, and tangent.
Sine, cosine, and tangent. So, ca, and toa. So how could I find...
You can do,
So that'd be
let's just cosine of 30,
Yeah, cosine of 30. Very nice.
and then you would have h over 2.
Equals h, which is the adjacent side, over 2, which is the hypotenuse.
And then
Right?
you get h.
Adjacent hypotenuse.
times by.
Bueno? So then, to get h by itself, I need to multiply both sides by 2. Only multiply by h if it's on the bottom, right?
By
Then you get 2 times cosine of 30, which is 1.73.
Gas. All right, so there we just found out, yes, you can.
Are all these statements gonna be yes?
Maybe.
How
You
would
scroll back
did
up.
we just say yes?
Yeah.
I wasn't done.
Do we have to explain?
You could say see previous page if you wrote this down on the previous page.
C. Pre. Page.
Math just makes me
Wait. Is that
You gotta write it down.
1.73?
Yeah.
1.73.
Or did you see the show on the screen? Paul? Or did I thought the others left? That's why.
They did, but I sacrificed my prep to come see your guys' beautiful
Did you
artistry.
like Logan's song?
Yeah, I liked all of them.
That's our favorite one, I believe.
Yeah, that one, Elegance, and World Wanna Know are my favorites.
All right.
Elegance is amazing.
Elegance is the best.
It's just very wonky steps.
Let's see, Mr. Ball. Here's
Samantha, do you need a regular sized pencil?
cash.
Instead of a golf pencil? Or are you just like, is this a...
She has a regular size.
Is this just like, oh, that's from your, I thought that was from the golf course. I thought you had a golf pencil. I was like, Samantha just out here letting everyone know that she is in fact a golfer.
I know, I'm using my Texas-sized pencil that I got in Boston.
I remember that. That's so funny. Okay.
It's great, I saw it and was
You
like,
know it's
I need it.
Okay.
Can I go get a
Paul, let's just
pencil?
bring the
Yeah, that's fine.
Just say
Mr. Mom
nothing, we're
for
like-
singing
Just
right.
start using, just.
Musical theater performance tonight, right?
Yep,
My mom is sick, so she can't drive me. Do I walk down there, or
do it. It's good exercise. It's a nice day.
I can barely walk in a straight line. Looney killed me yesterday.
Nice. It'll actually going for a walk will help
Yeah,
you
I know,
loosen
I
up.
know.
We should probably start.
I've
All right.
for a while walking.
The length of the sides of a triangle that form chords in the circle could be found using trigonometry. That means, could we have found this using trig? Mia says,
Five letters?
No.
Yeah, I think
No.
could we have found this side using trig?
Okay,
Yes.
yes, you can
Just
use.
the one side, yes, but the both probably not.
Well, if
Yes.
you find the one, could you then find what both of them are together?
Oh,
Okay,
yeah,
right?
Yeah,
I mean,
yeah, yeah.
without one side, then probably.
Okay, so if we didn't know what these were, how could we do that? Let's refer to that angle up here.
Yeah, do the sine, cosine thing, then,
So which one will it be? Sine, cosine, or tangent of 30?
sine.
Yeah, because this is opposite
And same-
and hypotenuse. So we'll use sine of 30 is equal to the opposite side over 2, which is the hypotenuse. I'll call that opposite for now.
and then
Let me write op.
top, and then times by 2.
Multiply both sides by 2. So the opposite side is equal to 2 times the sine of 30. Which is what?
One.
Yep.
Yeah, exactly 1.
Very good. So then what would this be right here? If this is the opposite side, what is the entire thing? 2 times the opposite side, right? 2 times opposite. And in this case, the side of the hexagon is 2 times 1, which is 2. Okay?
There's a hole, a small hole in my paper for my trumpets.
God bless you.
So yes. See.
Are we? Are you gonna give them teeth? They look like they bite.
They look like something you would see in the Muppets.
They look
But
like they.
also not.
They look like they bite.
Now they definitely do.
Like
What do you mean, Michelle? They just want to
It's
give
like
you a nice hug.
greater
No, they
than
look like.
less than.
No, they
Yeah.
look like me when I wake up in the morning. Kidding.
I woke up like this. Okay, so now based off of what we know, we could see that this, we know what the whole perimeter is. Because it's 2 times 6, right? But how could we find the area now?
Illustrate and describe your.
2 times pi r squared.
Pi r squared.
I got them both.
So we could do pi r squared. Well, that's of a circle, right?
Yeah.
So that would only help us for the circle. We need to find the area of a hexagon. And now we know what h is, right? We know that h is equal to 1.73.
It's the.
Oh, so we take that and find the area of the hexagon.
Yeah, so how could we, what do we have to find first, though? Can we just find the area of the hexagon, or could we?
Oh no.
I vaguely remember the equation, but I always forget it.
We,
Sounds like pig.
Yeah.
what shape do we have right here that we're working with?
A triangle.
Triangle. Can we find the area of a triangle?
Yeah.
Yes. If we find the area,
Good job, Sam.
if we then find the area of a triangle, this triangle, then we can multiply that area times 6. What is the formula for the area of a triangle?
1/2. No. Yeah,
Yes.
1/2 times height times width.
1/2 base times height. Yes.
Base times height.
So the base,
That's pretty
Based?
good.
Oh, sorry.
1/2 base times height, is the, oh my gosh, area of the triangle. What is the base of our triangle?
Rare. 2.
2.
Just right for a second.
And what is the height of our triangle?
1.7.
Oh.
Not quite. It's that thing we found in doing trig, right?
Oh yeah. Whoops.
1.73.
Not the side. Whoops.
So the area of our singular triangle is 1.73.
Oh.
Which then we can just not
Wait, that's the area?
That's the area of the single triangle.
Times six.
There are 6 triangles.
So then the area of the hexagon, which has 6 of these triangles, equals 6 times the area of one triangle, or 6 times 1.73.
It would be 10.
You went backward.
Because I was multiplying. Okay, there we go. So that is the area of the hexagon. We also don't know what unit we're in, do we?
We're in
Did you
7
say
point.
that-
So units squared.
Oh, whoopsie doops.
Oh, it says 2 inches.
What was that laugh? I am scared for my safety.
Okay, how about if Zach had inscribed instead an octagon with a radius 2 instead of a hexagon?
Just use the same method, except with 8 instead.
Use the same method, but with 8. So now, let's build our triangle real quick. Blech.
You give up
And the
this
angle measures would be the same, so.
Will they?
I
This
think-
looks more like
Yeah.
isosceles. It looks
Or
isosceles.
no.
It's because the last one was equilateral, right?
This one looks isosceles.
This one looks
45.
isosceles. How is it 45?
Because you do 360 divided by 8.
Ah, so this entire central angle is equal to 45 degrees this time.
What did I?
Because we did 360 divided by 8, which is equal to 45, right? So when I drop that altitude now, what is this new angle, half angle of that?
would it still all be equal since
22 by
it's just
5.
adding extra sides?
What do you mean, would it all be equal?
Would it also be an equilateral triangle?
No. It is still isosceles, but it's no longer equilateral, right? Because now we actually could know that these angle measures as well are, 67.5. Okay. So we know that the radius is 2. We don't know what the height is or the opposite side.
I use the trig function.
Use trig. Very good. So what trig should we use? What do you want to find first, the opposite side or the hypotenuse? Sorry, the height. Height. Let's find the height first. So what should we use to find the height? Cosine, very good, of 22.5 is equal to h over 2. So multiply both sides by 2. H is equal to cosine of 22.5 times 2. So tell me what that is.
I don't know. What is it, Mr. Ball?
Use your calculator.
Use your brain, Mr. Ball.
Oh.
1.84. I do not have trig ratios just memorized. I have some of them memorized, not all of them. So the height is 1.84. Very nice. What about the opposite side of just this? Remember, this opposite side is just going to be the right triangle, not the entire side of the octagon. So what trig should we use for the opposite side?
Sine.
Sine, because sine is so 22.5 equals opposite over 2. Multiply both sides by 2. And the opposite side is equal to 2 times sine of 22.5. Or, how to solve?
0.766. So
Why did
just
you
do
hesitate for
0.8.
so long?
0.8.
0.76. Very nice. So then the entire side of this octagon would be what?
Oh, let me do some math.
Wait, what?
So then the entire side of this octagon would be what?
1.52.
1.52. Very good. Because it is this opposite side times 2. So then the perimeter of our hexagon is 1.52 times 8.
That's it.
12.16.
And the area, what should we find first? Before we can just haphazardly find the area of the entire octagon, what do we need to find the area of first?
The triangle.
The triangle. So the area of the triangle is, what's the formula again?
1/2 times base times height.
1/2 base times height. What is the base of this triangle?
1.52.
And the height of this triangle?
1.84.
Very nice. So multiplying those together, you get
1.4-ish.
1.4.
Or you just do
One fish,
squiggly
2
lines.
fish, blue fish, red fish,
Mm.
3 fish, 4 fish, green fish, yellow fish.
Okay, so then the area of the octagon will be how much?
1.0.
1, 2,
Times that by
Yeah, it's 8 times the area of the triangle, so 8 times 1.4-ish.
Or 15.7.
wait,
yeah,
what? I got 11.2.
Yeah. 11.2 sounds a little bit more correct.
Yeah.
It is.
Yeah. I was like, where
What
did
did I do?
Wait, hold on.
What did I manage
Let's figure
to
this
do?
Let's figure out the problem that it was.
So if you do this and that.
Oh, I got it. I must have pressed the wrong number.
Yeah, I think you did.
Right.
I don't know.
Probably 1.8.
I don't know what I've done, honestly.
8 times 1.8. Yep, 14.4. That's not what you said. Maybe times 1.9. I don't know.
I don't know what I did, man.
Excuse me.
15.2 was.
Even I don't know what I
It was
did.
0.9.
Mm.
1.9.
All right.
Why
So
did you have to figure it out, man?
there we go.
Because.
So now we need to find, what if there was an n-gon, just any n-gon. We need to extrapolate this with any given radius. Okay?
How many sides are there?
Nope, there are n sides, Jacob.
Oh. Sides equals n.
Exactly.
Sides equals n. I don't like that.
So sides
What is the radius?
equals n. What does the radius equal?
Any given radius.
So what should we call it?
5.
No.
Terry.
What's a number that we could we could use r to represent any number that might be given to us. Very good.
5. No.
Okay.
No.
So what was the first thing that we found in all of these other triangles?
Angle.
The central angle, right? How did we find that?
Central angle.
It was a radius.
Oh, it would be 360 divided by the amount of sides.
Yeah, it was 360 divided by the number of sides.
But it's divided by n.
Right. So that's n in this case.
So we just leave it as 360 over n.
360 over n. Now, what did we do then? We dropped our altitude.
And then
So then what was this angle?
Central angle divided by 2.
Yeah, it was 360 over n divided by 2. So if we just are dividing it again by 2, we can go, this is 360 over 2n. Can we simplify that?
Yeah.
Yeah.
No.
No.
is what's 360 divided by 2?
180.
Oh, 180 N.
Yeah, so that's just 180 over n, right? That's nice. Now this hypotenuse is our radius. And we had to find the height and the opposite sides, right? So how could we find...
We're looking for height.
Okay, so we did height first. So we said height. How did we find height?
We used, which one was it?
Oh, we
Cosine.
used
Yeah, we used cosine of our angle. So what is our angle right now?
360 and, oh,
180.
180.
Yeah, 180 over n was equal to the adjacent side
And this is for
Over R.
over r.
And then times by
And then to get h by itself, we multiplied both sides by r. Pew, pew.
And then you get R times.
So the height was equal to r times cosine of 180 over n. You guys are like formula builders right now. This is kind of sick.
I don't like how you said that.
What did we find next?
The
The opposite.
Yeah, we found the opposite side.
So we need
well, we found the first part, and then we times it by 2.
So that we found the opposite side first, and then we found the side of the actual figure by multiplying it by 2. Yeah. So what trig function should we use for the opposite side?
sine.
Sine. Yeah. So we've got sine. What's our angle?
180
180. Say that again.
over N.
That a girl. Is equal to
OPP
the ops
over
over
R
r.
times R.
Multiply by r on both sides to get ops by itself. Woo! I'm going to put these just in a little box so that we could see them a little easier. All right. Cool. Now the entire side of the figure, right? Was 2 times the opposite side. Or 2 r sine of 180 over n.
2 R sine. Oh.
So then to find the perimeter, what do we need to multiply that by?
It was the sine. It
By
was,
N times
side times how many sides, so n.
yeah.
So it's 2 times n times r times sine of 180 over n. Whoa!
What was that noise?
Don't worry about it.
You look so happy though.
Yeah.
Number 2.
Oh, poop.
2.
Over n. My bad. Ah!
2 is technically just an and sideways. I'm just saying.
Oh, that's facts.
Area of triangle.
Oh, yeah. So now we've got to find the area. To find the area of this whole figure, we've got to find the area of the triangle. Which, what's the formula for the area of a triangle?
1/2 base times height.
1/2 base times height. So what is the base of this figure? It's the opposite, but it's the side of the figure, right?
So it's
2R sine of 180.
2r sine of 180 over n. And then what's the height of this figure?
It was
Yes? r cosine of 180 over n, right?
oh my goodness.
Oh my gosh.
And then now you need to do whatever. I don't know how you would word it, but it's the area of how the shape itself. So
Yes.
the,
So we'll call this an n-gon
okay.
equals what?
Wait, what are we doing?
So that was the area of the triangle, but now we need to multiply that by...
So So we take all
times
that and
2
times it by
r
n.
sine of 180 over n times r cosine of 180 over n times n.
Times the number of sides. So we take the number of sides times the area of a triangle. Also, just real quick, what's 1/2 times 2?
4, 1/4.
Yeah, we can simplify this.
No, I'm kidding. No, that's not right.
It's just 1, right? And what's r times r? Oh, I'm sorry, I didn't hear you.
Or
Yeah, it's just r squared, right? So now we're going to take n times this is just 1, so I don't actually need to include that. But I do need to include r squared times sine of 180 over n times cosine of 180 over n. What? You guys, this is sick. So here we've got 2 pretty solid formulas for finding both the area and the perimeter of polygons if we've only been given a radius of the circle in which they're inscribed and the number of sides. That's all we've been given. Dang.
What's the top?
What?
The H. H equals R times.
I don't know what you're saying. I'm confused.
I probably do have it, I just don't have it saying H equals.
Oh, gotcha.
So, we're gonna go to the bathroom.
Yes. We're done.